Okay. I only got you to go to 35, right? Up to 35. So you know what? I think you deserve a full-on example before I let you do this on your own. Okay, so I will do that for you. I won't. I'll try to keep pace here. Okay, so go to 33, and we're gonna go through that example together. And if you fill this in, awesome. Then you can just like focus on me talking about things and bringing things to your attention that you may have just followed my first video and be like, yeah, I'm going to fill this in, but now I want you to understand, right? Let me just go back a little bit. What is it that we covered? We started to use Normalcdf. This is if you want percentage, right? The probability. And so they have to give you values. It could be weight, volume. It could be z-scores, guys. It could be z-scores. They could give you anything, and they're like, hey, what percentage of values are above or below this or between? That's when you use Normalcdf. It needs 4 entries, remember. Lower limit, upper limit, mean standard deviation. Sometimes you don't have a lower. Sometimes you don't have an upper. That's where you just put in a very small number or a very big number. It depends on the situation. Inverse norm does the opposite. Inverse norm is when you have questions where percentages are given to either the right or the left of the curve, and you always want to focus on getting the percentage that is below it or to the left of the value you're trying to find. Okay, that's when you use inverse norm. And make sure you turn that into a decimal. Don't leave it at 65 or else you'll get the wrong answer. And so we had inverse norm, we practiced it, we came up with a couple of examples. Like if the question says, hey, if this is the value that puts you in the top 20, you're like, okay, that would put me somewhere up on the curve. And at this income, you'd be considered in the top 20. Notice that it would kind of be saying this is the minimum to put you in the top 20. You could be making more, but this is like the cutoff income to put you in the top 20. Top 20 indicates to the right of the value. We figured out the left, right? Knowing that it's always 100% under the curve. And that is what we put in here. And then followed by mean and standard deviation. So inverse norm only needs 3 values, okay? So there's that. So let's keep going. And I did ask you to draw your curve. But this curve, I only wanted you to have for reference purposes. Okay? I didn't want you to use it to answer. I wanted you to use inverse norm. And I'm just going to quickly make this curve here. Okay, so this was 250. And so 1, 2, 3. And you're already done. I've looked at some of you. It's good. It's all good. Just bear with me here. And if it's a nice round number, it's perfect, right? 250 is my mean. You go up and go back here. Try to make it symmetric. Right, there we have it. And this is mass or weight. Weight in grams. We have that. We section this off. And I was thinking, if you memorize half of this, you know the whole thing, right? If you memorize like 1/2 here, 34, 13.5, 2.35, and this is 0.15%, then you just copy it, right? And so this curve, as is, only helps you if you know the exact values that actually lie in here. But most of the time you won't. Like most of the time, it's actually not there. Oh, it's, did it ask for z-scores? Okay, z-scores, this would be a 0. So a mass of 250 would indicate a z-score of 0. This would indicate 1, 2, 3. -1, -2, -3. So listen carefully. you could technically block this off, right? And if all you have is that, your mean is 0, your average is 0, your standard deviation is 1, right? Because watch, 1, 1, 1. You're going up and down by 1 full unit, okay? If I say, hey, what about this one? If you're dealing with those numbers, look what's in the middle, 250, that's my average. And I can tell that my standard deviation is 5. So they work interchangeably. If I watch this carefully, if I said what percentage of values or bags have a mass between 250 and 255, you would have to enter your mean of 250 and your standard deviation of 5. You would get 34, approximately 34. If you did the same thing with using z-scores, you'd have to go, what is between 0 and 1? My mean is 0, my standard deviation is 1. You would get the exact same values, like percentage-wise, for either one of these. So they coincide, okay? They coincide. So using this or this is the same thing. You have a different mean and standard deviation here. You have a different mean and standard deviation when you're using z-scores, okay? You're like, why would they do that? Why would they have that? It comes in, the main reason why we have z-scores comes in a little bit later. It's to compare. Like, for example, if you have a z-score of 1 on a test and your classmate has a z-score of 0.5, you that have a z-score of 1, you did better overall, right? 0.5 would put you here, right? And if you have a negative z-score, you're below the average, right? Positive z-score, you're above the average. So keep that in mind. It tells us basically how many standard deviations above or below the mean you would be located. Okay. All right, let's keep going here. I might go off script here because that video was made a while ago. Okay, so I'm always adding to my lessons here. Watch this. It says use technology to answer the following. Okay, very important. I'm not saying use the graph. This is for reference purposes only. Okay. Calculate the probability or percentage. You could also say likelihood of bars weighing between here and here. So you notice immediately that these values don't even appear here. But if you could put them somewhere, 232 would be somewhere here, and 273 would be somewhere in here. So you know it's quite a bit of the curve, right? So that's just to give you a reference. So in this case, it would be Normalcdf, and you get an upper and a lower. So this is easy. 273, 250, and 5. And we multiply that by 100, right? And I'm just going to go off my key here. You get 99.98% of bags. That's the likelihood of them weighing, having a range. Okay, this is the range here. A range between here and here would encompass 99.98% of bags. Okay. Here's where I might go off script. If you don't have room, maybe just watch. But you could figure out the z-score for this and the z-score for that. Do you remember how to do that? There's a formula for that. I don't know if you remember. Okay, let's figure that out. 232 has a z-score of 232 minus 250 divided by 5. My calculator. Clear. It's 18. Negative 18, I should say, divided by 5. That's negative 3.6. And I was wrong earlier. 232 would have been here somewhere, right? Not here. It would have been below 235. I was wrong earlier. 273 has a z-score of 273 minus 250 over 5. I just want you to see this, right? 273 minus 250 divided by 5. That's 4.6. Whoa, like that's way past Mr. Dirksen. This is like over here, over there, right? That's okay. So now we'll use these values to try to answer the same question. So using z-scores, right? We go normal CDF. My lowest is negative 3.6. My highest is 4.6. And what's my mean and standard deviation here? I'm using z-scores. 0 and 1. Okay? Because I'm using z-scores. This is the mean. This is the standard deviation. So I'm going to use the second vars. Normal CDF. Negative 3.6. 4.6, 0, 1. And there it is, times 100. 99.98% of values, of bags. Okay. So this is where I go off script a little bit because I'm assuming you did this already, so now I can like insert another level to it, right? So if you use z-scores or the actual values that are present, it's up to you what you want to do. Okay. Calculate the percentage of bags heavier, right? More than 257 grams, basically, heavier than that. So because it says percentage, it's normal CDF, you want 257 is the lowest, right? And then this is the highest. What did I use on my key? I used 10,000, it seems. 10,000. Could I use 20,000? Sure. Can I use 100,000? Sure. Okay. I'm going to stick with 10,000 for today. Multiply that by 100, and I get 8.08% of bags are expected to weigh more than 257. So where's 257 at? Let's go up here. 257 will put you right about here. But notice that this is not a square. It's not a rectangle. It's not like if you're halfway, it's 13.5 divided by 2. It's not. It's tapered, right? But this is where we're approximately located with that weight. So you want everything above that. So it's 2.6, or sorry, 2.5 with these two. And then a little sum here. And then there's a little bit of a, right, sliver. So all of that is 8.08 exactly, okay? Next, percentage of bags weighing less than 243, less than, right? So 243.5 or less. So normal CDF. I think I go negative 10,000. That's assuming that I use this booklet for your video. I just found a video there and I posted it. And I could see some of you give it a try, right? So this, if you multiply it by 100 to get percentage, you get 9.68. Just make sure you show me the entries, because if you went negative 100,000, there's a chance that your value is a little bigger, and I'm okay with that because you've shown me you understand. Oh, I just need to make sure I take as much to the left of the curve as possible, all the way up to this point. And I'm fine with it. I'm fine with that, right? Okay. Here next, the company disposes of any bags weighing less than this, and any bags weighing more than 262, right? What percentage of the bags would the company dispose of? Okay. What did I do in my key? I'm curious. I did the direct method. There's an indirect method as well. Okay, I'm going to stick with the script because it's going to affect your notes if you did it. So less than 239 grams. I'm going to figure that out. That'd be normal CDF 230, oh sorry, I want everything less than 239, so I need to go as far to the left as possible, all the way up to 239, and that is 250 and 5. And let's multiply by 100 and get that answer. More, right? More than 262. Normal CDF. And more. So 262 is the lower limit, all the way to 10,000 grams. And then it's 255 times 100. I'll tell you what these answers are. 1.39% and 0.82%. So we reject this and this, right? Anything below a certain weight and above a certain weight. So we need to combine these. So that would be the equivalent of 2.21% of bags expected to be rejected, right? Do I do indirect in the video? I don't know. I'm not sure. You know what I'm talking about. Some of you might not. What did I do here, guys? Let's look at the curve here real quick, right? Like that. I figured out this percentage here, right? Below a certain weight, and this curve is not very pretty. And I have a little bit of a chunk above it. So I'm basically finding this 1.39%. So it's the percentage under the curve and this percent, right? And I add them up because I will reject some here and I will reject some here. So in total is 2.21. What you could have done, are you ready for this on a Monday? You ready? You go 100% minus, you figure out, you use normal CDF to find how many bags, the percentage of bags that would be between here, right? So you go normal CDF, 239 to 262, right? 239 to 260. I just want you to have a big picture of what we're doing here. You could have figured out this and subtract your answer from 100, which will then leave you with the little outskirts here. Crickets, 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 right? I think I'm going to just leave it for now, but that's another option for you if you like to do that, okay? Normal CDF, 239 to 262, you'll figure out the percentage that make it, right? Those are the bags that make it. You take that away from 100%, you're left with this, right? So you should get this answer when you do it that way. Anyways, let's keep going. If the company produces 5,400 bags per day, how many bags would be removed from the production line? That's just when you just use your answer, right? So you turn that 2.21% into a decimal, you multiply by 5,400 bags. According to my key here, you get this as a number, and then you just go approximately 120 bags. You're like, wait a minute, that's rounding up, Mr. Dixon. It's not rounding down, but my teacher always told me if this is less than 5, right, you round down. I agree. But in production world, you would actually make sure you say, hey, probably 120 just to be safe, right? You're saying we're expecting this many rejects. If you had gone 119, I'm fine. Just go a whole number within the context here. So those were related, those two questions. I could have made that just one question. So you would have to know that you first have to figure out the percentage, then multiply it by the actual number of items produced. What percent of bags have a weight with a z-score between negative 0.6 and 1.34? Wait a minute. Right? I don't know, I don't do comics, okay? But z-score, I know that I know my standard deviation, my mean. I don't need to know it, actually. I could have completely just avoided all the information I gave you. And that's another beauty of z-scores, right? It's based on a mean of 0 and a standard deviation of 1, okay? So here, percentage of bags, so you know it's normal CDF. So it's negative 0.6 to 1.3401. I'll tell you a secret. If you don't type in those two last entries, just go like that, normal CDF will assume that it is 0 and 1. But I have found that students make mistakes if they do that. So I always encourage you to just go 0, 1, okay? Because then they forget to do that. They'll just put in the first two entries for anything, forget to put in the mean and standard deviation, and then it's just a whole nother issue that I have to deal with, right? All right. You know, I talked about I want my standard deviation small. It's things like this that make sure that it's my standard deviation is small, because I'm kind of standardizing everything, right? Let's just do it this way, and then we won't have those mistakes that will affect you in the long run. If you do this, you get, where am I here? I lost my, oh yeah, here, 63.56% of bags will have a z-score between here and here. Mr. Dirksen, I was looking at this over the weekend, and I was just wondering, could I have turned these z-scores to actual values, like actual masses, and then done the normal CDF, right? Because this has an actual mass associated with it, this has an actual mass associated with it, and the answer is yes, but it's too much work in my opinion, right? Like turning both of these to the actual mass, then using normal CDF, and you would have to make sure you use 250 and 5 here. Then you get the same answer. Absolutely. Everything is connected, right? Let's keep going. Calculate the actual weights that correspond to the z-score above. Okay, that's why I just said that. What would the percentage of bags between these, would they be the same? Would the percentage of bags be the same? And let's do that just real quick here. To get the actual score with a z-score of negative 0.6, right, it's z-score times standard deviation plus the average, right? It's probably, yeah. This gives you 247 if you type it in one shot. And then we'll do it one more time for this other z-score of 1.34. 1.34 times 5 plus 250. And that gives you my pages are here, 256.7 grams. And that's the normal CDF. Normal CDF, 247, 256.7. But now you have to use 250 and 5. You cannot use 0 and 1 anymore, because you'll get the wrong answer. And lo and behold, you get the exact same answer. Same answer. Perfect. Exciting stuff, eh? All right. The company would like to know the weight. Now we're going inverse norm territory. Okay, pay attention. How do you know that, Mr. Dirksen? Because it doesn't ask me for a percentage. In fact, it gives me the percentage. And watch, remember the 68, 95, 99.7? Those numbers we know, right? But this one is nothing, it's not an exact, it doesn't apply to that rule. Okay, so let's read it again. The company would like to know the weight, actual value, right? We want the actual value here. That would place 65% of the bags produced below this weight. Okay, so I'm going to do this here on the side. Imagine your bell curve. We know it's normally distributed. If 65%, so remember this is 100. If 65% of the bags are below this weight, then you would have to kind of make the mark here somewhere. Because if you had it in the middle, you'd have 50 below, 50 above, right? So this is actually, and within this context, they're giving you the percentage to the left already. Okay, that's what they're doing now. So we would have to use inverse norm, 0.65, right? Turn this, right? Divide it by 100, and then turn that into a decimal, and then followed by 250 and 5. And you get 251.93 grams. Okay, that is the value along the x-axis, right? That kind of is the cutoff for where you have 65 below and therefore 35 above you. Okay, so this is below and this would be above. Okay, and we know this is 35%. The company would like to know at what weight would 6% of the bags produce. Oh yeah, there's a typo. Let's see how I fix it. The company would like to know at what weight 6% of the bags produced would be heavier than it. Okay, so in this case, if only 6% are heavier than you, you're still higher up here, right? If you say here 6%, it would be below you, right? So we are somewhere in here. So 6%. This is what we're after, the weight that would put us there. So this would be 100 minus 6, which is 94%. This is what we want. 94% would be weighing less or would be below that weight or something like that. So inverse norm, 0.94, 250, and 5. And if you type this in, second vars, right? Remember, everything is second vars when it comes to these ones. Option 3, 0.94, 250, 5. Second vars is where it's at. So 257.77. And what are we in right now? We are in grams, right? So it's whatever is along the x-axis. Watch this one here. This one is interesting. Determine not the weight, determine the z-score of a bag that is heavier than 55% of the bags produced. Right? So watch this. Make a little bell curve. The bag would be heavier than 55 of them produced. So technically, they're telling you, right? This bag with that weight would be heavier than 55% produced. So this is, we want the z-score here. There are a couple ways of doing this. Two for sure. Let me show you the easiest. You go inverse norm, 0.55. And because it's the z-score that you want, you just plug in 0 and 1. Okay? This is your mean. This is standard deviation, right, of 1, right? So if you plug in 0 and 1, you get the z-score. If you plug in 250 and 5, you're not going to get a z-score. You're going to get the actual weight that is associated with the z-score. So watch this. We're going to get, if we do this, you get, oh, what did I do in the notes? Yeah, I see what I did there, but just follow me here. A z-score doesn't have units. Watch that. Okay? So this is the z-score, right? This is 0.13. You're done there technically. Or you can do it this way. Inverse norm, 0.55, because that's still a percentage to the left. 255. Inverse norm, 55%, 255. What is this going to give me? Well, because I'm using grams, right? It's going to give me the actual weight here. Let's figure that out. In my notes, I have 250.63 grams. So you can, under this, also say that the actual score or the actual mass corresponding to that z-score is 250.63. They're one and they're basically interchangeable. A score has a z-score, and a z-score has its actual score. Okay. And you could now actually, if you had figured this out, guys, watch carefully. This, you could actually use the formula for z-score as well to come up with it if you wanted to. Okay, so z is 250.63 minus 250 divided by 5. Okay? So that would be 0.63 divided by 5. 0.63 divided by 5, which is 0.126, which is rounded 0.13. Okay? So the or is very important, but I will highlight this part. Right? That if you had used inverse norm straight up like that, you get the same answer. If you had used inverse norm but using the 250 and the 5, which are the actual values, you get your actual mass, which you can then use with the z-score formula to figure out the same exact information as before. And that's why it would have been like, if you're scratching your head on a Monday, right? Like if you did this on your own, I think right now it's just time to give it another spin, right? To see how everything is connected. And 2 more questions on the back. I'm not even sure if I did this in the, yes, I did. It's part of the booklet. Determine the z-score of a bag that is lighter than 31% of the bags produced. And I feel like I may have made a mistake on my key here. Moses brought it up already. So let's see here. In my key, I think I made a mistake. Let me read it again. Determine the z-score of a bag that is lighter than 31% of the bags produced. A z-score of a bag that is lighter than 31%. I think I'm good with my key. I think I agree with my key, because if you put that score here, if you're interested in that z-score, that would put you in a position where this bag is lighter than 31% of the bags produced. It's just the wording is a little weird, and I did that on purpose, but this z-score would put you're lighter than 31%. If you put that here, I'm gonna cross this over, okay? If you said this, If you said this, you're saying you're heavier than 31% of the bags produced. So this is, okay, heavier than 31%, right? This is lighter than 31%. That looks like chicken scratch to me, but it says lighter than. All right. So because of that, I need to figure out this one and this side, and that would be 100 minus 31, 69%. And so we go inverse norm. Inverse norm. It's asking for z-score. So again, right, you know, okay, my mean and standard deviation are set. So I'm going to go 0.6901 and you're done. This is the quickest way of doing that if you have enough information. And we get, according to my records, 0.5. 0.5, 0.50, no units, okay? If you would have, I'm just checking here, inverse norm 0.69, and use 250 and 5, you get this as your mass, right? And then using the formula, so that'll be this minus mean divided by standard deviation, you still get 0.5 positive. So Moses, I'll come and see you maybe later to clarify that. Yeah, I stand by my key. Right? Okay. Determine the z-score of a bag weighing 259.25 grams. And I don't know about you, but it's Monday, right? And you're not into this stuff. You're like, I don't know. What should I do here? You can most definitely not do this, okay? Don't do this part, because some students hear what I say, 0, 1, 0, 1. Okay, I'm just going to do this. Inverse norm. Oh, I can't do that because I don't have percentage, right? Can't do it. Inverse norm doesn't work. Need percentage to left or right, for that matter. It needs to. If you had that, bingo, you're good to go. But you don't have that information. Okay, so doesn't work, right? And in this case, use your z-score formula. If that ever happens to you, use this one. So you go 259.25 minus the average divided by standard deviation. And that gives you 9.25 over 5, which gives you 1.85. Never put a unit next to z-score because it doesn't have one. Okay. What does this tell us? I think I put that down, right? This tells us, if I asked you to explain this, what does that 1.85 tell us? Well, it tells us a couple of things. It tells us that at 259 puts us above the average because it's positive, right? And a bag weighing 259.25 grams is 1.85 standard deviations. And here's the kicker, above the mean. You can also say it's heavier than the average. Why is that? Because z-score is positive. Okay. So that's an added. If I ever asked you to explain what is a z-score, that's what that is. Okay. Okay. I'm gonna not do the AC. because it's closer to the end. So I want you to have some time to just practice these skills. I want you to try. I have another one like this on 36 and 37. So pretend like this is an AC. Pretend like maybe even a quiz. And you can watch this. It says use technology, right? I don't want you to use the graph. I just want you to graph it so you remember how to do it, because I will ask you to do it. And also to make a reference back to it. Like if you find some answers and you go back, it's like, does that make sense? Like, oh yeah, right about here. Okay, yeah, that makes sense. My answer kind of adds up, right? So go ahead, 36 and 37. Instead of RAC today, basically making you do homework in class. And then we'll reconvene